All right, guys. So today we're talking about quadratics again. We're going to kind of build off of everything that we've been talking about thus far in my prior videos. What we're going to be talking about today in particular is focusing on writing quadratic equations instead of just having given the equation. What if I gave you some information that pieces of an equation that we could use to piece together and create the overall function and then see the picture of it? Okay. So we've talked about two forms thus far, and we're going to get a little bit more specific in particular with vertex form. So just kind of remembering just some things that we've talked about. Standard form. We know that equation was y equals ax squared plus bx plus c. If I asked you to write that form, and if I gave you a, b, and c, we could do that by simply just substituting those letters for their respective numbers. So this equation would be y equals negative 3x squared plus 18x minus 15 because that c value is negative. Now, vertex form, like we've discussed, is the same graph, but it's a different form. Okay, so this form represents the same kind of function as a standard form, but it looks a little different. And in particular, the equation is a times x minus h squared plus k. Now, obviously, there's two different variables here that we haven't really discussed. Those two variables are going to be h and k. Now, all h and k represent is that vertex, which is why it's called vertex form. This form is really nice for us to instantly be able to pull out that vertex that we can't so easily get in standard form. Okay, so if I just gave you a function and said, what's the vertex? You could find it by these two values. So in this case, okay, if I give you the vertex, which is h and k, if I say the vertex is 312, okay, we also have to write our a value, because if you notice, a is still in this formula. A is still here. The a value in vertex form is the exact same a value as standard form, which is pretty convenient. So that a value here is going to be negative 3, because I got that from over here. I'm on my first form. And then when I'm writing the form, it's going to be x minus, keep in mind, the sign flips with that h value or the x value of my vertex. Okay. X minus 3 squared plus 12. So one thing you guys might notice is that the sign of the x value of my vertex is opposite in the equation, which should always be the case. Very similar to when we substitute into point slope form, how the signs flip. The same thing here happens in vertex form, but just for the x value. Now keep in mind, why do we use h and k? Okay, the reason why we do that is to just separate the specific point of the vertex from all other points, because the vertex is a very special point that determines our maximum or our minimum. So we want to kind of point that single point out in particular versus all of the other points on a graph. So we give that specific coordinate a specific letter, which is h and k. So that's all the letters mean. Okay, is anything in the place of h and k is always going to represent our vertex. Okay. So this is how we're going to be writing our forms. We're always going to want to find an a value in vertex. We're always going to want to find an h, and we're always going to want to find a k. So what we're going to be talking about is, what if I gave you a vertex and then just some random point that also exists on my graph of the quadratic? And I ask you, what could you give me the vertex form? So what we have to think about is, what information am I giving you? So the information that we're given is a vertex in some random point. We just talked about above that the vertex is represented by two specific letters, h and k. And I want to keep those things in mind, that these two values, 4 and 10, are going to represent h and k. specifically. Now, keep in mind, any other point on the graph is represented just by some x and x comma y. That's all it is. Get my colors in order. So this is just some generic x comma y on the graph. So I'm going to use that information and I'm going to actually substitute them into the vertex form. So keeping in mind that my vertex form, like we talked about above, is y equals a times x minus h squared plus k. Think about what we have so far and what we can substitute. So far, and I'm going to highlight what I have. I have an x value, which is 6. I have a y value, which was 4. I have an h value, which is also 4, and a k value, which is 10. What do I not have? My a value. So in order to write my vertex form, what we're going to have to do first, and really only, is we need to find this a. So how I'm going to do that is I'm going to substitute all 4 of these numbers into the vertex form, and I'm just going to solve for a. So we're going to be substituting h, k, x, and y into vertex form. To find my a value. So I'm going to start that up here. So how I'm going to do that is just going to write the vertex form first, just so you guys can see where the numbers are going in the formula. So interesting k, here we go. So I'm just going to substitute my numbers in. My y value was 4. I don't know a. My x value was 6 minus my h value, which was 4 squared, plus my k value, so the y value of the vertex, which is 10. So I've got to solve this out very similar to what we've talked about in past videos using my order of operations. Okay. So in order to solve this first, okay, what I want to do is to multiply this guy out, or let's just simplify this. 6 minus 4 squared, well, 6 minus 4 first is 2 squared, which then 2 squared becomes 4. So a times 4. Now, we don't have to write it this way. This is kind of weird. So instead, I'm just going to flip that orientation and call this 4a plus 10 equals 4. So I just did 6 minus 4 is 2. 2 squared is 4, and then times a. So subtracting 10 from both sides, that gives me negative 6 equals 4a. Dividing everything by 4, we can write this as a decimal if you want, or as a fraction. It's going to give us negative 3 over 2, which is equal to negative 1.5, is equal to a. So this is perfectly fine. So I can use a fraction or a decimal. Really doesn't matter what you want to do there. I'll just keep it as a fraction. So when I'm writing the vertex form, it's going to be y equals negative 3 over 2 times x minus 4 squared plus 10. So in vertex form, I only want to use the a value, the h, and the k. The x and y are only used to find the a value. Now, finding standard form here, what we have to do is exactly what we did on my last video. We're going to work out vertex form and change that into standard. Okay? So I'm going to kind of make myself some space over here. Okay. Changing to standard. So what we have to do with what we're given, if I'm given negative 3 over 2, x minus 4 squared plus 10, I'm going to multiply this guy out, which you guys can do that. It's going to be x squared minus 8x plus 16. And then everything else around it is still existing. I've just multiplied that x minus 4 squared out into x minus 4 times x minus 4 and multiplied those. Okay. Now I'm just going to use a distributive property here. So I get negative 3 over 2 x squared. I'm just using my calculator. Plus 3 halves, or negative 3 halves over, or times negative 8 is positive 12x. And then 16 times negative 3 halves is negative 24 plus 10. Keep in mind, this plus 10 comes down now. So all I have to do now is to combine these two guys. And my final answer is going to be negative 3 over 2x squared plus 12x minus 14. So really the second part that I just did in standard form, I went a little quicker because it's something that we've already discussed. So I spent most of the time and most of my space working out the new thing for today, which is finding that vertex form using the h, k, x, and y. Now, like I said, one thing we always want to do is to check by typing both of our equations into the calculator and comparing the values. Okay. So I already have some things prepped for today for us to talk about. So if you notice, this was my vertex form. Okay, I already have it prepped for us. And the standard form I got was this. So if we notice, both of my equations are the exact same line, like we've already talked about. So yes, both forms represent the exact same line. Now, it asks me, using a table, what is the value of y when x is 10? Might be a little confusing for some of you, but you just got to think about, what are they giving me? Oh, they're giving me an x value of 10. What if I type that into Desmos? Okay. Which, oh, look, I have it there. And it gives me a line. It wants to know what's the y value. So really, I'm just going to find where these two lines intersect. So let's take a look at it. Oh, look, they do intersect. The red line represents x equals 10. My black line represents either my vertex or my standard, doesn't matter. And they intersect at the y value of negative 44. And that's all we're finding. So that last question, whenever they're asking, find the y when x is this, or find the y when x is this, find the x when y is this, find the y when x is this. My wording's a little weird. We're just typing that into Desmos and finding an intersection, okay, which makes it easy. So I'm going to move on. Going on to number 5, the exact same thing. Okay, now it's just practice. Think about it. I'm just giving you a root. Now, this kind of plays into some vocab that we've already talked about. Understanding that a root is just a point on the line, because a root represents the same thing as a solution or a x-intercept. Whatever you want it to be, it can represent a zero of the function. It doesn't matter. All we need to know and all we care about is that that's a point. That is some random point on the line. Because what I've also given you is that vertex again, which is h and k. So my root is going to be x comma y again. So just like we did last time, what we're going to do is we're going to substitute h and k in this x and y into vertex form and solve. So given that my vertex, once again, is y equals a times x minus h squared plus k. I want to find this a value. So how I'm going to do that is plug in all 4 of the numbers into this formula. So my vertex, which was 1, so it's going to be minus 1 here, squared plus 3. My x value was 2. My y value is 0. I'm just reading across. I'm just plugging in my h, k, x, and then my y. I was just reading from left to right. So if that looked a little weird, I apologize. So my y value was 0, so hence it's 0 there. My x value was 2. My h was 1. And my k was 3. So now all I'm going to do is just work this out. So 2 minus 1 squared is the same thing as just 1 squared, because 2 minus 1 times a plus 3, and I have a little bit more space to work this out. So 1 squared is just 1 times a is just a. You can write 1a if you want. It doesn't really matter. Plus 3 is equal to 0. So solving this for a, I'm going to subtract 3 from both sides. And I know that now that a is equal to negative 3. So all I have to do now is write the equation using a, h, and k. So in this case, y is equal to negative 3 times x minus 1, because that's my h value, squared, plus my k value, which is 3. So like I said, when I'm writing vertex form, which I'll just write underneath, vertex form, I really only want a, h, and k when I'm writing the equation. When I'm writing equations, we never replace x and y unless we're finding something. Hence the reason why we did that prior. We had to find the a, so I had to substitute that x and y value in. Okay, so this is my answer. Now, changing this guy to standard form, nothing new. So I'm just going to go ahead and write this up here. Changing to standard. I have negative 3 x minus 1 squared plus 3. You can put the y there, but nothing's going to happen to it. So multiplying this guy out, keep in mind, I have a little bit more time to just go back. Keep in mind, x minus 1 squared is x minus 1 times x minus 1, which then when I multiply that, turns into x squared minus 2x plus 1. So if you were confused last time, that's how I got that. And then we bring down the a value, and I bring down that k value, because I haven't used them yet. So now order of operations, I'm going to multiply. So I get negative 3x squared plus 6x minus 3 plus 3, because that 3 at the end, once again, comes down. I haven't used it yet. Now to finish it off, just combine my like terms. So what I have is that negative 3 and 3 combining, which cancel each other out, which is fine. Telling me that all I'm left with is negative 3x squared plus 6x, which is my standard form. Okay. And I don't ask you to check, but just like we did last time, if you wanted to, you could go to Desmos and plug those two guys in. I've already gone ahead and done that for us. So this was my vertex form. And my standard form is this guy. So once again, if you notice, they're the exact same equation, which tells me I did something right. Okay. Now, what if I give you a table? Kind of weird here, because you don't really have a vertex. Well, you do. We just don't know which one it is yet. But we do know that we have points. So I'm talking about time and height. Keep in mind, whenever we talk about time is always x, meaning that height is y, okay? It's always an independent variable. Time moves freely. We can't control it, okay? Now, what we have to do is to find which of these 4 points is my vertex. That's the most important thing. So how we can do that is by typing in all 4 of my points, which the points they gave us were 0, 15. They gave us 1, 20. They gave us 2, 15. And they gave us 3, 0. Now, from the pictures here, which these are my points, I can find the pattern of my graph. So if you notice, from over here, on this point, from this point to the next point, it's increasing. But then what does it do right after that? Oh, it goes back and decreases, and then it's decreasing. So think about it. What would be my vertex here? Okay, because I've only given you 4 points. There's obviously a lot more in these representing graph. Hopefully you say this guy, because if you notice, it has that maximum. So it goes from here to increasing, and then from the vertex, it decreases again. So it has that point or the top of the mountain, then it goes back down. And then we can assume it's going to continually go back down. So whenever you graph this, look to see, is my graph, does it have a high point and goes down, or does it have a low point and then goes back up? That's how we can find that, because we know my graph follows that kind of horseshoe or U shape, okay? So that's the best way, is graph the points and then identify where's the lowest point or where's that highest point, okay? Which in this case, this is the highest point on my graph, because we can assume once I graph this, there's a lot more points that would just continue to be below that, okay? So the best thing to do, guys, like I said, is graph it and find where it goes from up to then back down, or down and then going back up. So I know now that this is my vertex, okay? And keep in mind, we want to graph our points. So I have my vertex, which is 120, and now I can just pick any point I want for x and y. It really doesn't matter. It doesn't matter. I'm going to get the exact same equation and the exact same a value regardless. So me being lazy and looking at the 3 values I have, okay, I want to pick the easiest numbers, which for me is going to be this guy. This is going to be my point, okay? It doesn't have to be that point. I'm just going to pick it. As long as it's not the same point as the vertex, it must be a different point. So I know my vertex, just going to write the information I know. I know my vertex is 1, 20, which is HK. Just going to write that to identify it. And I know my point that I'm using, I said, is 3, 0, which is going to represent XY. So keep in mind, I'm using these 4 values, once again, to find that A value. So finding vertex form. So I'm going to substitute into vertex form, which I'm just going to write it again. It's good to have a process. So substituting y, x, h, and k into it. So my y value was 0. My x value is 3 minus my h value, which is 1, plus my k value, which is 20. So I'm just going to work this out now and find that a value. So 3 minus 1 is 2, and 2 squared gives me 4. So I'm just going to write that as 4a plus 20, because that 20 just comes down. It's been there the whole time. Keep in mind this is also equaling 0. So solving this now for a, I want to subtract 20 from both sides. So I have negative 20 equals 4a. And then dividing everything by 4 to get that a by itself, I know that a is equal to negative 20 over 4, which is negative 5. So using that now, that information, I now know that my vertex form is y equals negative 5 times x minus 1 squared plus 20, which I can write up here. So the only difference with a table is you want to pick any point on the graph and find the vertex. And the best way to do it is to find or is to graph those points, like I said. Because what we know is that whenever I graph points, which this is kind of what I got last time, my graph, if I wanted to connect those points, I know it would look something like this. So that tells me that that's my vertex. On the flip side, if my points did follow that same trend, my graph would do something like this, which would tell me to find the vertex. Okay, and that's how I find it. So keep in mind, if you can't identify it just by looking at the table, graphing it is your friend. Okay, and that's how you find that vertex. So let's go ahead and move on. Got 2 more and then we're done. Now we talked about a table. What about a graph? What if I already gave you the picture and tell you what's the vertex form? Yes, I agree with you. We can find the vertex from this already. I know my vertex is here in this case. This guy is 2, 4. I know that. But keep in mind, I still don't know the a value. What I'm also highlighting for you is just a point on the graph. Now, really, you can pick any point on this graph because this is technically a point. This guy down here isn't. So really, we can pick any one of these two. I've already made your life easy, and I've given you the point 0, 2, excuse me. So I've given you all the information that you need. Now, we're just going to follow the same process. If I know my vertex is 2, 4, which once again, that's HK, and the point that I'm using is 0, 2. These are the guys that I'm going to substitute. HK and X and Y. I'm going to plug these guys in to my vertex form. Because keep in mind, what is it asking me? Standard form. So I have to find a vertex first and then change that guy to standard. So what I have here is y equals, I'll write it a little smaller, equals a times x minus h squared plus k. So my numbers, when I plug them in, are 2 equals a times 0 minus 2 squared plus k. Oh, no, excuse me. Plus 4. K is 4. Like I said, keep in mind where I got those numbers. This 2 came from the y because it asked for y. This 2 was my h. The 0 was the x because it's x. And k is 4. So I just plug those numbers in. according to whatever it asks me to do. If it says K is this, K is now a number, and then so on and so forth. Working this out now, this guy here, 0 minus 2 is negative 2 squared. Negative 2 squared, so negative 2 times negative 2 is positive 4 times A, plus 4, and then we just solve it from here. So I'm going to subtract 4 from both sides, which gives me negative 2 is equal to 4A, dividing both sides by 4. I know A is going to equal negative 1/2 or negative 0.5. It doesn't really matter which answer you give me. Okay. Let's write that a little bit better, which is equal to negative 0.5, which is equal to A. So any one of these is acceptable. I like personally to keep things as fractions. If you want to write it as a decimal, that's perfectly fine. Now, to write this in standard form, okay, so this is step 1. Step 2 is standard form. I'm going to write that vertex form out, which is y equals negative 1/2 times x minus 2 squared plus 4. I'm going to work it out. So like we've talked about, this guy is technically x minus 2 times x minus 2, which turns into x squared minus 4x plus 4. When I multiply that out, and that negative 1/2 and the plus 4 are still out there. Obviously, this is always equal to y. So I'm going to multiply this guy out, which now gives me, let's zoom in a little bit. Separate my work. Y equals negative 1/2 x squared plus negative 1/2 times negative 4x is positive 2x, because 2 negatives is a positive and half of 4 is 2. And then negative 1/2 times 4 is negative 2 plus 4. Keep in mind this plus 4 comes down. Now we're going to combine. So my standard form is y equals negative 1/2 x squared plus 2x, and then negative 2 plus 4 is positive 2. So that's going to be my standard form of this graph. Now, a great way to always check yourself is, like I said, graph the function if you need it. Okay, if you want to check it, feel free to plug that guy in, whatever you'd like to do. Okay, because if you graph these equations, you should hopefully see this picture pop up on Desmos, which would tell you I did it correctly. So the last one, got to use some keywords here. Everyone's favorite thing, word problems. Now, the nice thing about word problems is they're really always going to give you the vertex by just a couple keywords. Because what we know in word problems is that my vertex is always my highest or my lowest point. So, some keywords that we want to look for is max/min. Okay. We always want to look for also starting point. Okay. Is what represents my starting point here? Or is there a point? Okay. So looking at it, in this case, it says to demonstrate the crushing weight of gravity on a foreign planet, the International Space Station uses a Land Rover to launch a baseball directly upwards from the ground to a maximum height of 27 feet in 3 seconds. So just in those last couple of words, I got everything I needed, okay? Because there's that keyword maximum, okay? If it's at a maximum height of this, of 27 feet in 3 seconds, what do you think that represents? My vertex. Now, we've got to keep in mind, we're talking about seconds and feet for a height. So keep in mind, okay, time is going to be x, and my height is going to be y, just like the last problems we've talked about when we talked about height and time, okay? So I know that here is that my vertex is going to be 3, 27. Now, what they also told me is that where did I throw this from? Oh, I threw it from the ground. And if I start something, what's the time, or what is the starting time of anything that I do? If I'm about to throw a ball, how do I represent if I haven't thrown it? Okay? Time is 0. So no time has passed if I haven't thrown the thing yet. Now, if I'm throwing it from the ground, what is that height? 0. Excuse the sneezing in the background. That's my dog. So I know that this is a point 0, 0. That's what they're telling me, is this is my starting point. And a great thing to keep in mind is that the ground always means 0, 0. Okay? If I'm saying I'm starting from the ground, that's what I mean. So starting point. Ground equals 0, 0. So I know my vertex right now, and 0, 0 is just my x-intercept because the y value is 0. Because if I were to plot it, wouldn't this point be on the x-axis? Yeah. Doesn't matter how you call it. It's still a point. Just in this case, it just happens to be an x-intercept. Now, they want to know when it's going to hit back or smack back onto the surface. So I've got to find my equation. We're going to graph it and find where it hits again. So let's go ahead and do that. Obviously, if I have a vertex and a point, that's all this is. I'm going to do the same thing. I have y is equal to a times x minus h squared plus k. So hopefully by now, we know what 327, 0, and 0 are going to represent on this equation. Y is going to be the y value of the point that I gave you, which is 0. A, I don't know. X is 0. H is 3. And K is 27. H, K, X, and Y. That's where I got those points. Now, plugging these in, I have A times negative 3 squared, because 0 minus 3 is negative 3. Negative 3 squared is negative 3 times negative 3, which is positive 9. So 9a plus 27 equals 0. Subtracting 27 from both sides, I get negative 27 equals 9a. So from here, it's going to be negative 27 equals 9a. Divide both sides by 9. So 27 over 9, or negative 27 over 9, is a negative 3. So I know the vertex form now is going to be negative 3 times x minus 3 squared plus 27. So really now what's nice is that I can find when it's going to hit the surface again. Because that's the question they're asking me. They're asking me, use blue, is how long will it take for the ball to smack back into the surface? So let's graph this equation that we found. So here's my equation. Notice I started at 0, 0, because that means I threw it from the ground. So when does it hit the ground again? Notice I reached the high point of the vertex that was given to us. It hits the ground again after how many seconds? 6. Okay. So that's my answer. Now, when it's asking how high is the ball at 1.5 seconds, we need to think about what is they giving me? Is seconds X or is it Y? So it's a time. So what they're saying here is if X is 1.5, what's Y? Okay, so what we can do here is we can graph 1.5, X equals 1.5, and find where that intersects. Or if you want, what we can do is with our equation, we could also replace that with 1.5, which will then give us the exact same Y value. If you see what it just gave me, 20.25. It really doesn't matter if I graph the line separately or if I substitute it. It's going to give me the exact same value regardless. So my graph, or the height at 1.5 seconds, is at 20.25 feet. Now, what they're giving me for the next question is, when is the ball at a height of 24 feet? So here, what they're giving me is Y equals 24. So what's going to make my life easy is same thing. I'm going to graph this. So what if, with my equation, I graphed Y equals 24? If you notice, how many times do these lines intersect? 2. Okay, because think about it. When I'm throwing that ball, it's going to hit 24 feet as it's going up in the air. It hits its high point, and then it hits 24 feet again when it's coming down. So it's going to hit it twice. So it's going to hit 24 feet at 2 seconds and at 4 seconds. So with that, guys, we are done for today. Seems like a lot of information, but there's a lot of repetition involved. Keep in mind, use these notes as a guideline. If you are confused, please make sure that you're reaching out to your teachers. Please make sure that you're using their online conferences or their office hours so you can get on there and get some help. For my kids, you should know when that is. Monday, Wednesdays, and Fridays, depending on level or honors. Please make sure that you reach out to us. Make sure that you use us as a resource and get these done in a timely manner. Okay. Thank you guys so much for your time. Have a great day.